A multimeter set to measure current records the current as 85 milliamps. The voltage across R1 is 1.20 volts, and the voltage across R2 is 3.60 volts. What is the value of the two resistors? So here we have the resistors connected in series with one another, and we're told what the overall current is. Now what I want to do is I want to point out to you how we measure current. So let me erase part of the diagram like that. And if we want to measure current, what we need to do is we need to take an ammeter like that and insert it into the circuit like that. And we know that in a series circuit that I total is equal to I1, which is I2, which is the current anywhere in that loop. So we'll say IN. So we are given that the current, let's write this information down on the side, perhaps in the margin. We're told that the current IT is equal to 85 milliamps. Now we know that milli means times 10 to the minus 3. Okay, so that's just a metric prefix. So we know that this is the same thing as saying 85 times 10 to the minus 3 amps. We just replace the milli with times 10 to the minus 3. And if we were to write this in standard notation, that would be 8.5 times 10 to the minus 2 amps. And that's because the multiplier here is always written between 1 and less than 10. Okay, so we now know what the current is throughout the entire circuit. So let's state that IT is equal to I1 is equal to I2, and we found that that's equal to 8.5 times 10 to the minus 2 amps. So we're going to need that information to do our calculation. Okay, so now let's do R1. R1 is unknown. We know from Ohm's law that R1 will be equal to the voltage across R1 divided by I1. So the voltage reading, let me add a voltmeter here to show you how the voltage was measured. Let's do that for R1. What we have to do is attach our voltmeter on either side of R1. So our voltmeter, let's represent it with a V like that. That's a standard symbol. And one arm or one probe goes to one side of the resistor, and the other probe or the other arm of the meter goes to the other side, like that. And that will give us the voltage reading across R1. You notice that the ammeter is connected in series. It's part of the circuit where the voltmeter piggybacks the circuit. It kind of spies on the circuit by putting its arms on either side of R1 without interrupting the circuit in which R1 is present. Okay, so let's go back to our calculation. We know that R1 is equal to the product, or sorry, the quotient V1 divided by I1, which would be 1.20. That's the given voltage, divided by the 8.5 times 10 to the minus 2 amps. Check that on your calculator, please, on your own. I'm going to make sure that your calculations agree with mine, and you'll also want to make sure that you catch any mistakes that I make. That happens from time to time, as you know. So R1 works out to 14 ohms, rounded to the whole number. Okay, my pen's not behaving well today, but that does say ohms. Ugh. Here, let's erase that. Okay, and try again. So let me do it in a different color. Still doesn't work. Well, that does say 14, and that is supposedly an ohm. I think I need to kind of give up. So it's 14 ohms. How about that? Even that doesn't work. Okay, it's a bad day today. Okay, so let's try the next calculation, R2. R2 is going to be equal to the voltage across 2. Voltage across 2 is given as 3.60 volts, so we know that. And we know it's the same current, I2. So plug in the numbers. R2 is equal to 3.60 volts divided by 8.5 times 10 to the minus 2 amps. So plug and chug into the calculator, and we get R2 is equal to 42. Don't understand what's happening with the pen today. 42 ohms. That does say 42. Trust me. Check your calculator. Maybe I need a new battery. We'll do that after this video. Okay, last question I want to add. I just want to throw this in. What is VT, or the total voltage? VT is the total voltage of the circuit. Okay, so we know for a series circuit, VT in the entire circuit is simply equal to V1 plus V2 plus Vn. Okay, so we just have to add up all the voltages in the circuit. And since we have two resistors, that means we have two voltages. So VT is going to be equal to 1.20 plus 3.60, and that's going to be equal to 4.80 volts. Okay, so that's going to be, for a series circuit, the total voltage.